Hi guys. Today we're going to be talking about lesson 6.2, day 2. We are going to talk about what happened when Mrs. Gallus decided to uh, use permanent employee wages and randomly assign them using this probability distribution, which is X. And then she also gives them an annual hourly raise, and we're going to see how that factors into our probability distribution when we add those two things together. So let's find the mean and standard deviation and variance of the first two probability distributions, and then we'll see what happens when we combine them together. So the first thing we're going to do for the mean, if you recall from past lessons, is that the mean is your sum of your X values times each respective probability, and then you add them all up. So for this particular one, we would take 9 times 0.3 plus 12 times 0.45 plus 15 times 0.25, and you get a mean of 11.85. Standard deviation and variance, remember, found with the formula, the square root of the sum of your xi's minus your mean squared times each respective probability. So if we were to do that, we would have 9 minus 11.85 squared times 0.3 plus 12 minus 11.85 squared times 0.45 plus 15 minus 11.85 squared times 0.25, and that would give you a variance of 4.93. And if I were to square root all of that, that leaves us with our standard deviation, which is 2.22. All right, now let's take a look at the mean, variance, and standard deviation of the probability distribution Y, which is for the hourly raise. So your mean would be 1 times 0.7 plus 3 times 0.3, and that gives you a mean of 1.6. And then if we're trying to find the variance, that would be 1 minus 1.6 squared times 0.7 plus 3 minus 1.6 squared times 0.3. That gives you a variance of 0.839. Square rooting that, which gives us our standard deviation, would be 0.917. 0.917. So there's the work for mean and standard deviation of both of those probability distributions. So number 3 leads us into what we're going to talk about next, which is letting N be the hourly wage and combining both of those hourly wages and the hourly annual raise. So what are the new possible wages? Well, you can have a wage of $10 because 9 plus 1 is 10. You can have a wage of $12 because 9 plus 3 is 12. You can have a wage of $13 because 12 plus 1 is 13. You can have a wage of $15 because 12 plus 3 is 15. We can have a wage of $16, and we can have a wage of $18. Those are our possibilities moving forward. So then it says, what is the probability of having being assigned a $9 wage and a $1 raise? So the key thing here is that your probability distributions X and Y are independent of each other. And when that happens, we can figure out this and probability by just multiplying the probability of a $9 wage and a $1 raise. So the probability of having a $9 wage was 0.3. So that would be the probability of a $9 wage and a $1 raise is the 0.3 times a $1 raise is 0.7. So that would be a probability of 0.21. So now let's calculate that for every possible wage moving forward. So from 3A, we could have 10, we could have 12, we could have 13, we could have 15, 16, and 18. So we found the probability of 9 and 1, which is 10, so that's 0.21. And then finding that probability for each one of them. So a $12 total wage would be including 9 plus 3. So that'd be 0.3 times 0.3, which is 0.09. $13 wage would be a $12 wage and a $1 wage, which is 0.45 times 0.7, which would be 0.315. $15 wage would be $12 and $3, so that's 0.45 times 0.3, so that would be 0.135. And then 16 would be a $15 wage and a $1 raise, so 0.25 times 0.7, and that is 0.175. And then for the $18 total, it would be 0.25 times 0.3. So that gets us 0.075 for that $18 total, 0.075. Now, if we were to recalculate the mean and the variance and standard deviation for each one of those. So for the mean, we would take 10 times 0.21 plus 12 times 0.09 plus 13 times 0.315 and so on. You would get a mean of 13.45. And then finding the variance, remember you take the value, so 10 minus 13.45, square it and multiply it by 0.21 and do that for each one. Adding those all up together gets you a variance of 5.76, and square rooting that variance gets you your standard deviation of 2.40. So as an overall rule for this idea that we just discovered, if you're taking a probability distribution and you have two distributions, in this case X and Y, what you can do to find the new total is you're going to take the mean of the X and the mean of the Y's, which you would see if you added 1.6 and 11.85 together, you get 13.45. For the standard deviation, it's a little bit different. What you're going to do is you're going to square both the standard deviation of your X values and the standard deviation of your Y values, and you add them together and then square root them. So we can't just add plain standard deviations. We have to square them first to make them variances, and then you square root them to get back to the standard deviation of the new total. So in this case, if you look up at your original distribution, your standard deviation of the wage was 2.22. And you would have to square that, and you would have to add it to the standard deviation, which was 0.917 squared for the hourly raise, and then you would have to square root them in order to get this new standard deviation. So now we're going to talk about some of those rules or reiterate them in your important ideas part. So I'm going to zoom in on this. Okay, so just as a little rundown, when we're adding or subtracting, so if we, let's erase that. All right, so if we are adding or subtracting two random variables, X and Y. So the means of X plus Y would be the mean of X plus the mean of Y. The standard deviation of X plus Y, you have to remember, square the mean of X, add it to the square of the mean of Y, which is your variance, and then you have to square root them. So this is adding. And then if we're talking about subtracting, so the mean of X minus Y, so the difference of those two random variables, you're going to take the mean of X minus the mean of Y for subtracting. And the standard deviation, though, this is something that's a little tricky and you want to make note of. Even with subtracting, you're going to square your variance or square your standard deviations to make them variances. But this is the key here. Even though this is for subtracting, your variances still get added and you take the square root of this. So that's not a mistake there. That's on purpose, that's addition, not subtraction, no matter what, if you're adding or subtracting the two random variables. So in order to create this new normal probability distribution, what's important for you to remember is that you find the new mean and standard deviation first before you do the problem. So let's take a little scroll down into the check your understanding part. You have these two cars sold and cars leased, and they're trying to total them. So you have to do basically what we did up above, but then they ask you a question. Just keep in mind down at the bottom that you're going to have to actually do a little of what we did yesterday in order to figure out number 3. So 1 and 2 is what we did today. 3 is what comes from the lesson prior. Remember, if you have any questions, make sure you make it to office hours, and I'll see you there.